Well, welcome back. Today we're talking about energy again. What I want to point out to you here is we've had some equations, and they're starting to add up, obviously. Um, but here are equations. I don't know if there's anything on here that's missing, but down here at the bottom are the ones we've just added this week. But at any rate, okay, without going any farther, let's start talking about it. Okay, in this problem, we've got a 2,000 kilogram uh, roller coaster. It's on top of a 100-meter hill and it's not moving. What we want to do is, what is its potential energy and kinetic energy at the top of the hill? Well, first of all, the kinetic energy is easy to calculate because kinetic energy is 1 half mv squared. The v component, well, it's not moving, so the kinetic energy is 0. The potential energy is mgh. The mass is 2,000. Gravity is 10. The height is 100. We found out that potential energy is 2 million joules of potential energy. All right, it's all potential because it has height. Right? It has a height of 100 meters. It has no kinetics. It's not moving. What is its potential energy and kinetic energy at the bottom of the hill? Well, the potential energy now is easy because it's mgh. M is the same, gravity is the same, but height is 0. Height is 0, so everything else, it doesn't matter. We're multiplying by 0. The potential energy is 0 joules because it now has lost all of its height, so it doesn't have any potential energy. Where's all that energy gone? Well, all 2 million joules here have gone into kinetic energy. There's really no math to do here. This is a concept. We're just understanding that if it doesn't have potential energy, it's had to go somewhere. It doesn't just disappear. All right, energy can't just disappear. It's gone somewhere, and it's now in the form of kinetic energy. So that means it's moving. What's this roller coaster now doing at the bottom of the hill that it wasn't doing at the top? It's now moving, and it's moving probably really fast. Okay, this last part is for you guys who are a little bit more gifted. What is its velocity at the bottom of the hill? Well, its kinetic energy is what I'm going to use. I know that the kinetic energy is 2 million joules, so I've placed 2 million joules in for the kinetic energy. I know the mass is 2,000. I multiplied by 2 to get rid of the 1 half. That gave me 4 million. I'm going to divide by 2,000. Now I take the square root of both sides, and we get V is equal to 44.7 meters per second. Okay, there's other types of energy as well. We have elastic potential energy. That's the energy of an object that is stretched or compressed. This would be for something such as a spring or a rubber band. These would both have elastic potential energy. Mechanical energy is the energy associated with the position and motion of everyday objects. For example, the roller coaster. As it's coming down, let's say it's halfway down the hill. So here's our roller coaster. Person's going halfway down. So there's the roller coaster. Well, at this point, the mechanical energy is equal to, well, it's got height. It's got height, so it does have potential energy, but it also is moving. So it's got kinetic energy. So what we find out is the mechanical energy is the combination of whatever potential energy it has and its kinetic energy. Okay, a football is kicked. Well, we're going to talk about all three of these topics. Where is work done? Well, when we kick the football, work is done. That's my football there, not a very good football. When the foot comes up and kicks it. So the foot applies a force, and there's some distance that the foot remains in contact. So the work then is equal to the force times the distance. Right? The force that the foot kicked it with and the distance that your shoe or foot stayed in contact with the ball. And that's how much work was there. So let's just, say you kicked it with a force of 100 newtons and you made contact for half a meter. So there was 50 joules of work. Well, the kinetic energy, all right, as soon as your foot lets go of it, it's now got 50 joules of kinetic energy. Why? Because it has a velocity. Right. Now, as soon as it comes off your foot, That football, it's going up, right? Well, as it goes up, it also starts to gain height. So eventually what's happening is the velocity is going down, the height is going up. Eventually at some point the velocity is going to be 0 meters per second. It gets clear up to the top, and right here the velocity is 0 meters per second. What's it going to do at that point? Well, what I do know is at that point it has no more potential energy. Or sorry, it has no more kinetic energy. If velocity is 0, the kinetic energy goes to 0. So now we can say that the potential energy is 50 joules. Okay, this football's got 50 joules up here because it's got some height. Well, eventually this football's going to start coming back down. As it goes down, its potential energy is going to decrease, and its kinetic energy is going to start to increase because it's gaining velocity. So it starts off with 50 joules, and it's going to go to 0 joules of potential energy as it continues going down. Eventually, right before somebody catches it, its kinetic energy is going to max out at 50 joules. And then there's going to be some receiver here in a football helmet, all right, that catches the football and then takes off running. Well, how much work does it take for him to catch the ball? Well, if it's got 50 joules of kinetic energy, the work, as the kinetic energy now goes to 0 joules, he must have done 50 joules worth of work to catch it because he applied an upwards force for some small distance that was equal to 50 joules. Well, hey, that's it for today. I'll catch you guys on the flip side.